Welcome, this is an IXL support video. Specifically, we're going to be looking at cluster Y and the fourth assignment listed there, Y4, the one that's called slope-intercept form, find the slope and Y-intercept. So as that first question for this assignment loads up, I'm going to make my whiteboard a bit larger for now, and I want to focus quickly on this idea of slope-intercept form. Slope-intercept form is one way to write all of the linear equations that we come into contact with. Those linear equations do not have to be written in slope-intercept form, and there's plenty of times you'll find linear equations that are in some other form. But whenever linear equations are in slope-intercept form, they're always going to look or be built and solved for y. The y will be all by itself on the left side of the equation, and it'll be built in this y equals mx plus b style or form. The reason we call this slope-intercept form is that if the linear equation is written in this y equals form, it's really easy to identify the slope and the y-intercept just by inspecting or looking at the equation. If it's in this y equals form, whatever number is all by itself, what's represented by the plus b here, that number all by itself is your starting value, your y-intercept. Because remember, a y-intercept is the value for y when x is 0. And if I make x 0, it cancels out the whole mx situation and would just leave the b. So for that reason, the b is the y-intercept. Slope is our rate of change. It describes how much y grows by for every 1x. And if the equation is solved by y, whatever number multiplies with x tells you the slope. It's literally telling me how much the y will grow by for every single x that gets brought in. So recapping the big key, if it is in y equals form, whatever the m is, the number, the coefficient of x, that's going to be your slope. And whatever the number, the constant number all by itself is, the b in this situation, that's your beginning value or your y-intercept. So when I look, let me make the whiteboard a bit smaller now. As I take a look at this next problem, or this first problem, it says y equals 6x plus 8. That's our linear equation, and because it's in y equals form, it is indeed in slope-intercept form. So the b is going to represent my y-intercept, whatever is all by itself. And in this equation, give me 1 second to load the marker tool. In this equation, it is the positive 8 that's all by itself. So I'm going to go ahead and circle that positive 8. That's the plus b, and that represents my y-intercept. Now I have a new equation, the equation y equals 8x plus 5 over 7. And I'm going to try to zoom in a little bit to see if that makes it bigger and easier to read. So now we see y equals 8x plus 5 over 7. And they are again asking us to find the y-intercept. The y-intercept will be the plus b, the constant number that's all by itself and not multiplied with x. And in this case, that y-intercept is this positive 5 over 7 that we see right there. Keeping things moving, we see a third example that asks you to find the y-intercept. Pretty straightforward. We see y equals mx plus b. This positive 6 represents that y-intercept, that initial value for y. If I were to make x 0 and cancel out that whole 10x term, y would have to be equal to 6. That's my y-intercept. Now, for the next one, the problem asks us to find the slope of the line, and they give us this equation y equals negative 1 over 6 multiplied with x plus 2 over 5. Recall that the y-intercept is the b, the constant that's all by itself, and the slope is the m. It's always going to be the number multiplied with x, or if we're getting fancy with our math language, the coefficient of x always represents slope. In this case, the number that's multiplied with x, or the coefficient of x, is this negative 1 over 6 right there that is multiplied with x. So that's going to be my slope. Here, conveniently, the equation showed up in the same place. They happen to ask about slope again. I know slope is whatever number multiplies with x. So in this case, our slope is going to be negative 1/3. I'm going to plug in a few more answers quickly without talking through them too much. They asked me for the y-intercept. I'm looking for the plus b. So that's going to be our 9 over 10 here. Again, they're asking for y-intercept. They were nice. They put it in the same exact location. I see this plus 3/7. The thing that's added to the 4x represents the initial value for y, or the y-intercept. This time they ask for slope. That will always be the coefficient of x, in this case negative 1 over 5. And I believe this is pretty straightforward. I'm going to plug in a few more answers to see if they throw any curveballs at you. But I think at this point you should be in great shape to do this assignment on your own and use their explanations to learn the rest of the way. Okay, here's one that's somewhat tricky as we get up into the 80s and 90s, and we'll run through a few of the trickier ones here towards the end of the video. Here, I see that x doesn't really have an m. There's no coefficient. But if you remember from Mr. Neville last year, whenever the x is all by itself, it's really a 1x. So here my slope is 1. Each x I bring in will make y grow by 1. That's why the slope is 1. Here they make the numbers a little more annoying. Negative 85 over 26. You'd have to check if it could be simplified. It can be simplified. 1, 2, and 13 or 26 is only factors, and they don't go into 85. All right, the challenge zone. Sometimes the y-intercepts will be negative. I guess that's the challenge here. So if I see they're subtracting instead of adding, I'm going to have a negative y-intercept. Sometimes I'll have a negative slope. In that case, slope is negative 34. And I believe we're going to get to the challenge zone here with pretty straightforward problems. Okay, cool. Like you see, that's a pretty straightforward IXL assignment. They're just preparing you for future ones where you're going to be asked to create your own graphs from these equations or find the equations that match up with graphs. And understanding the slope-intercept form is a big piece to that. Thanks for watching to the end. Thank you for the great work.